Hi everyone, welcome to Ace with Ease. Today we're going to be doing exponents. Okay, so it's just gonna be a little introduction of exponents, and we're gonna be introducing a few laws of exponents. Okay, so firstly, exponents are basically an expression that is in the form something with a little something on top. So it's read a to the power b. Okay, it's a to the power b, where a is the base and b is the exponent. Okay, so before we can even go any further, you must know that any number raised to the power 0 is 1. Okay, and any negative exponent can be written as a positive exponent. It's just that the positive exponent will now be the denominator. Okay, don't worry too much about it. It's just something that you should be aware of as we go into the laws of exponents. We will deal with it as time goes on. Okay, so the first law of exponent that we're going to look at today says that when you multiply the same basis, you just add the exponents. Okay, so like we've explained, that the bases are the parts that are underneath, basically. So this and this would be the base, a to the power n. In this case, a would be the base, a to the power m, a would still be the base. Okay, so what this law is saying is that if you are multiplying two numbers or two variables that have the same base, okay, what you do is just add their exponents. Okay, so it means here you just write the base, the common base, write it down, and you add the exponents. You say n plus m. You have a to the power n plus m. Okay, let's look at a second example. 2 to the power 3 times 2 to the power 2. Okay, again we have the same basis, it's 2. Okay, so you write down the basis and you add the exponents because you are multiplying the same basis. You'll have 3 plus 2, which is 5, and 2 to the power 5 is 32. Okay, it's advisable to always simplify your answer. Don't just leave your answer as 2 to the power 5 because it can be simplified. Okay, so that you get an extra run. Okay, so let's go to the next one. 3 to the power 2 times 3 to the power 1. Okay, again you have the same basis. Okay, and you are multiplying them. So what do? You just add the exponents. What are the exponents? Is 2 and 1. 2 plus 1 because we're multiplying the same exponents. So what is 3 to the power 3? I think I made a mistake here. 3 to the power 3, that's going to be 27. Okay, so then that's going to be it. Okay, 3 to the power 3 is 27, and that's it. Okay, so that is law 1 for us. Says when you add the same basis, when you multiply same basis, you just add the exponents, which is what we did here. Okay, let's go to the second law. The second law says that when you divide the same basis, you subtract the exponents. So let's look at the first example. We've got a to the power n divided by a to the power m. Okay, so again in this instance you can see that we still have the same basis. Okay, but in this case we're dividing. Okay, so if you're dividing the same basis, the law says that we must subtract the exponents. Okay, so you'll just write the common base, which is a, and you'll take the first exponent, subtract the second one. So the first exponent in this instance is n, so you'll say n minus m. Okay, similarly in the second example, 5 to the power 3 divided by 5 to the power 1. Okay, so again we have the same basis, but in this case we are dividing. So because we are dividing, the law says that when you're dividing the same basis, you subtract. So we'll have 5 minus 1, which is 2. 5 to the power 2 is 25. Okay, again 2 to the power 8 divided by 2 to the power 2. Okay, this is we are having the same base again, same base, which is 2. Okay, and when we're dividing the same basis, the law says that we must subtract the exponent. So we'll say 8 minus 2, which is 6. So we'll end up with 2 to the power 6, okay, and 2 to the power 6 is 64. Okay guys, so yeah, that's it for this video. We're going to continue with other 3 laws of exponents in the next video. Hope you have learned from this video, and if you haven't subscribed, please subscribe so that we can be able to continue with other videos. Okay, thank you.